Ok, ya vamos a empezar. Ah, Hola, ¿cómo están? Ya vi que hay algunos en Twitch y hay algunos en YouTube. Vamos a empezar hablando un poco sobre la comunidad de C++ México y después tenemos a un invitado, Tim Chestnut de Google Drive. Nos va a estar hablando sobre las nuevas características de C++ 17 y 20 y cómo hacen mejor al lenguaje. Primero, ah, me presento, yo soy Bigfred. Esta vez solamente voy a ser el anfitrión, no voy a hablar ninguna charla, solamente voy a presentar aquí. Y si tienen preguntas, váyanlas pensando. Las pueden hacer en español o en inglés. Si son en español, les podemos traducir. Y esperemos que la plática va a ser en inglés, como la vez pasada, pero vamos a tener los closed captions. Y eh, también va a quedar grabada. Entonces no se preocupen si no entienden, después queda grabada en YouTube y pueden ver eh, con más calma. ¿Vale? Primero vamos a tener la presentación. Eh, Estos son los medios de contacto. Somos una comunidad de C++ México. Eh, Aunque el tema principal es C++, también estamos abiertos a hablar de temas relacionados con la programación de sistemas y temas que sean de interés de C++, como programar de alto performance o sistemas embebidos, etcétera. ¿Vale? Estos son nuestros medios de contacto. Principalmente lo que usamos es Twitter, eh, el Twitch, Telegram. Tenemos un grupo de Telegram y YouTube. Aunque la verdad les recomiendo que entren a Twitch. Y por ahí a lo mejor si hay gente que tenga el logo de C++ México que puedan usar en Twitch para que lo vean, pueden usar este logo, tanto en Telegram como en Twitch. Ahí está el Twitter. Como ven, como a la gente le gustó mucho el logo, crecimos un poco rápido, pero bueno, está bien. Y tenemos la página, ¿no? Aquí la página básicamente solo están los medios de contacto. Después de la sesión, de la presentación, vamos a tener una sesión de preguntas y respuestas, así que si tienen preguntas las pueden ir dejando en el chat, ya sea de Twitch o YouTube, y las vamos a guardar para el final, ¿vale? Hay gente que está recolectando las preguntas, así que no se preocupen por eso. Y bueno, otra vez esto ya no iba aquí. Ah, vale. So maybe Tim, you can start. This is Tim. Hi. Yeah.
Hello.
Uh,
Thank you for having me here.
yeah.
Let me
And
present.
yeah.
All right. Hello, everyone. Thank you for having me. My talk today is going to be on C++ 17 and 20, the better syntax and better features that have been added to the language. Brief introduction. My name is Tim Chestnutt. I'm a software engineer on Google Drive. I believe Victor just said all of this. I also work as a C++ instructor internally at Google, which is how Victor and I met. I've been programming in C++ for about 20 years professionally. I've been at Google for over 8 years. C++ is just a language I have worked a lot with, and I really like the language, and I like the changes that have come along with the new revisions. And so I'm excited to share what I see as the nice things in the language, and I hope this community continues to explore and develop these. So my talk tonight, I'm going to focus on sort of two categories as I see it of things that have been added. We have the better syntax and the better features. The better syntax are things that we could do previously in C++. This isn't something new. What is new is the syntax to do this is just much nicer than it was. And in doing so, this means we're more likely to actually do it. This is one of the problems that I saw, is that there were technically better ways to do certain things, but Because the syntax was a bit ugly, we didn't tend to do it. And now with that clean syntax, we can have better habits as developers to write code in better ways just by default with our new habits. And this is just a better coding experience. Also, we have some new features in the language, things that we couldn't do before. New library features that have been added, new features to the language. This gives us more power that we can use as we write our C++ code. But of course, with great power comes great responsibility. And so we have to use this new power carefully. There are ways to use this that gives you great benefit, and there are ways that can accidentally make you make lots of extra copies and reduce your performance. And of course, we don't want that. So we do need to be careful with it. But overall, these are still better things to have in the language. And with them and with the better syntax, this is all just a better coding experience. So better syntax. There are several things that have been added, but what I'm going to focus on tonight is just these three things here: better scoping, designated initializers, and structured binding. And better scoping actually covers three different things that have been added, some of them in C++ 17, some of them in C++ 20. But I grouped them all together. So the scope of a variable, of an object, matters because that defines the endpoint. When something goes out of scope, it is destroyed. And so we actually have a rule in the Google C++ style guide that we should place a function's variables in the narrowest scope possible. This is a rule in our style guide. This is a general good practice to follow in C++. This is something that says, I'm not going to hold on to memory longer than I need to. Because if you hold on to memory for a long time, then when you need more memory, you have to actually get more memory from the system because you haven't released the memory that you're done with. And in pathological cases, if you get lots of memory and don't release it because you keep holding on to it, you wind up having a very, very large memory footprint. So by going to the other extreme and releasing memory when you're done with it, you can wind up with a lower overall memory footprint. So for a simple example of how this plays out in practice, you could have an if statement, and you might get some object, hold it in a local variable, set up an if statement to look at some property of that object. And then if that's true, you'll go into the if statement and you'll do something with that object. And when you're done with that if statement, you're done with that object, but you don't throw it away. You keep it until it goes out of scope, which is going to be all the way at the end of the function. So you're done with that object bar, but you continue to do other things in this function. You might get some other object, you might hold on to that. You may have several cascading levels of these kinds of if statements doing various things. And that's not the best practice, but it is a common practice. In the old syntax, if you wanted to be very focused on trying to reduce the scope as much as possible, you could actually introduce some extra curly braces just to put in some extra scoping. So now you can create a bar object within that scope, look at it for the sake of going into an if statement or not, and then when you're done, your bar object is destroyed. But it's tedious to create this extra scoping every time you're going to create another object. Like, no one's going to bother doing that. And sure enough, people just don't do it. I mean, I have seen it in some circumstances when it matters greatly about the scope of a thing, usually with the scope of a mutex lock or something. But in general, the previous syntax where you just hold on to the object a little longer was more common because this syntax results in more vertical spacing, more horizontal spacing because you're indenting things a bit more. And that's just noise. Coding in general is something that you write the code once, but then you read the code many, many, many times, and many other people will read the code. So it's sort of a write once, read many things. So making the code readable is a big win for everyone. And having this kind of noise that just adds some useless lines and indents everything a little bit more, which might cause more things to wrap, which takes up more vertical space, that's just something that we want to avoid. So now we have this new syntax. We have the ability to put an initialization section inside of an if statement. So we can get the object just like we did before, but now it's within the confines of this if. So it's scoped to the if block. So then we can get the object, look at some property of it, process the object and whatever we're going to do, and then immediately throw away that bar object. We don't need it anymore, and so it can be destroyed. Then we can go on to get some other object and do the same kind of thing there. And this gives us, not a huge difference, but it does give us a lower overall memory footprint for this. And so it's something that gives us cleaner syntax. This doesn't take any additional lines of code. This doesn't take any additional indentation, but it gives us that cleaner syntax, and it gives us the better scoping and destroying things as soon as we don't need them. So this is something that I like to see, and this is something that I've embraced, and I've seen other people embrace, that we change how we write C++ now. Switch statements have also added this, where you can have a switch statement. You can get the object and switch on some property of that object, but now that object itself is scoped to the switch statement, and the bar will be destroyed before you move on. And range-based for loops, this has been added for C++ 20, where you can have range-based for loops. And I absolutely love range-based for loops. I was so happy when they were added to the language. You can just iterate over everything in container, and now you have the ability to get some object and tie the lifetime of that object to your range-based for loop. So you can get some object and iterate over some container within it, and then you're done, and you can throw away that object before you move on. So all of these things give us that better control of our scoping with very, very clean syntax. It doesn't provide any noise. So I'm a big fan of that. Designated initializers. Excuse me a moment. I love these things. They make, it's a fun gimmick that really just improves the syntax overall. So before designated initializers, if you had a struct with just a couple of things in it, how do you set the fields of that struct? You could create an instance of the struct. You could assign values to each field within it, but then your struct can't be const. If you wanted to create your struct and have it be const, then you need to pass in those parameters to an actual constructor. So then you need a constructor to say, take in these parameters and set them accordingly. But as soon as you do that, you lose the ability to just default construct it, unless you then go back and say, oh, wait, compiler, I really do want to have the default constructor. Please keep it in there. So that's a lot of boilerplate, a lot of noise. And if you have circumstances where you only want to set some of the fields of your struct, but not others, then you need more constructors for this struct that just take different numbers of parameters. And I've seen this done. I've seen a struct like this that had like 3 or 4 different kinds of constructors for it. And being able to throw all that away and move to the new designated initializer syntax is just such a huge win. Far fewer lines of code on the screen. Now you can clearly see the parameters of the struct. There are 0 user-defined constructors here. And when I create it, I just say, this is what I want to set these fields to. And it's even got the benefit of the names of the fields are right here. You can see the name of the field at the site where you're actually creating this. And recently, I actually went through this with someone in a code review where there was a factory function that would make an object, and it had constructors on that object. And we wound up, as we went through revisions of this, realizing it didn't need to be an object. A simple struct with some fields sufficed. And then we didn't need the constructors, and we didn't need the factory functions. We could just use designated initializers, and it removed a lot of code that, less code to read, less code to maintain. It's just a huge win. Designated initializers also play very nicely with default member initializers. Default member initializers are not new right now, but I like highlighting how they play nicely with this. So if you have a default member initializer here, so you can set a default value to a field of a struct, you can then, with your designated initializer, you don't have to specify every member of a struct when you use designated initializer. You can specify only the ones you want to set. And here, I'm setting the label to be hello world, and I'm not setting the level, which means it's going to be the default value and be the -1. So very clean syntax, and I really like this. Structured bindings is another fun one. This one, when I first encountered it, I thought, okay, that looks neat. I'm not sure how much I will use it. And now it turns out I'm actually using it quite a bit. So it's fun. It's a weird syntax. You can do this const.ref and then square brackets for variable names, and you're unpacking something else. It could be a pair, which is the most common use that I have for it. It could be a tuple. It could be various other things. So range-based for loops I've mentioned are something that I really like in the language. And if you have a contiguous container, you can just iterate over every element of that container and that's fine. But if your container is a map or any other associated container, now you're iterating over this over each node, and each node has a first and a second because it's a pair. And so I've seen plenty of code that uses range-based for loops to go process maps, but then within the context of the range-based for loop, it goes and does first and second every single time. And that's tedious, that's annoying, and you can kind of work around it by putting in these things at the top of your range-based for loop to say const.oref key is first and value is second, or better names than key and value. And I've seen that done, and it does make it more readable at the cost of more lines of boilerplate that you have to kind of skip over when you're trying to read for the actual contents of the code. But now with structured bindings, we can do for const.oref and then immediately unpack the key and value pair as we iterate over the map. So we don't have to have a placeholder iter or object or node or something like that as a iterating variable. Now we can just directly unpack it into key value and, of course, use more sensible names. Now we don't have to do .first or .second, and code that has real names for things and doesn't use .first and .second and get with individual numbers is just far more readable. I don't like seeing .first and .second in code. So that sums up the syntax changes that I really like. As you can see, they were things that we could do, but often didn't just because the syntax was tedious. And now we get nicer, cleaner syntax that lets us have these better habits. So moving on to the better features, these are things that we now can do that we couldn't before. In particular, I'm going to focus on inline variables and then a bunch of new things added to the library: optional, variant, string view, span, and source location. Inline variables. This is one that just seems minor, and like I really have only one line on this slide, but I was so grateful when it finally arrived and we could finally start using it. It is a common thing to need constants defined in your project, and you'll have like a common thing is to just have a header file with all of your constants defined and have like the name of your project and names of tables and names of individual sentinel values for various things. And just it's a common thing to want to have all your constants defined in one place, because you don't want to repeat your constants in like every file of your project. That's just a mess to do maintenance, especially if anything's going to change. And so having this ability to just have the constants in one place, use it, gives you, cleaner code. It's a good principle to use. Don't repeat yourself. But it turns out there were a lot of subtleties with how to define your constants. If you put your constants in a header, this often ran afoul of the ODR, one definition rule, because you'd put it in your header and you'd include it from multiple source files. Each source file would compile into an object file. They'd compile into different libraries. You'd link them all together, and now you're violating ODR. And so the workaround that we often used was to actually just have a function for each constant. So you could have a function defined in or declared in a header file, and then defined in exactly one source file. So it would compile into one object file and be in one library, and you'd link it in, and there's no violation of ODR. But that was just tedious and ugly and lots of extra boilerplate. And now we have inline. So we can just say inline const expression and just have a string and put it all here in one clean line. And it doesn't matter if it's compiled into multiple translation units. Like, this is permitted by the language now. So that was just a very nice thing to have. Lots of words, but that's because I really liked getting this feature. I was really happy when it finally landed. Moving on to optional and variant. These ones are some interesting ones that can be used poorly. This is where I said great power comes great responsibility. Standard optional is a useful thing for deferring construction sometimes. Sometimes you truly have a member of a class that might be set, might be not, or maybe you just have to defer when you construct it for various reasons. So generally a member of a class, you want to construct it when you construct the object. So you'll have the constructor, and in the initialization section of that constructor, you will just list out all your fields of the class, all your member variables, and initialize them there before you enter the body of the constructor. Like, that's good practice. but sometimes you have a need to not construct it there. And if you don't construct it there and want to construct it later, do you then default construct it there, but then override it later? Or how do you do this? And you could do this with unique pointer so that it would be, a null pointer, but then when you need it, you could do make unique and create that object. And that was a thing that we could do, but that meant that your class was located here, and then that one field would get allocated somewhere else in memory. And that loses, some of the nice benefits of having everything close to each other in memory, because there's a lot of memory caching. So having things close to each other in memory is a useful thing. Optional gives you that. You can have an optional member of a class, and it'll be in your struct. And then when you initialize that field, it gets initialized right there in the same block of memory, which is very nice to have. So if you're deferring construction of a member variable, this is a very useful technique. Where I've seen it sometimes used well and sometimes used poorly is when you put it at the API level, where you have a function and you have some parameters that are required and some parameters that are optional. And it's tempting to be like, hey, I have these optional parameters to my function. Let me use optional around this particular parameter type. And if your intent is to be a sink for that parameter and consume that parameter, that can be a very useful thing to do. It is now an optional thing. It could be populated with null opt, or it could be actually passed in by value, and you consume that in your function or in your class. That can be a useful thing. But if it's something that you're not consuming and is still intended to remain valid at the call site, then it gets messy, because then it basically winds up copying it into your class, and you don't want to just have pointless copying for things. So there are times where you would want to continue to have foo pointer rather than optional foo to represent an optional parameter for your function. So with that caveat, I like optional. I think it's a very useful thing. I've used it in several places, not a ton, but I have used that one a bunch. Standard variant is an interesting one. This is one that I've seen good talks about this, and there's been good discussion around it, and I haven't actually gotten the chance to use it myself. I highlight that this is not for polymorphism. A variant lets you hold a thing or another thing. So with optional, you could hold a thing or not hold it at all. With variant, you can hold this or that or some other thing, and that's okay. It will hold one of those things. And with polymorphism, we get you have an interface and you interact with that interface, and you can have multiple derived types. And so you kind of get this idea where you could have one of any of these derived classes. And in that kind of construct, you want to stick with polymorphism. You don't want to try and do a variant to say I'm an instance of this class or that class or this other class, where it's like, no, that should be polymorphism. So, be careful with using variant. You don't want to just use it everywhere. But where I think it is going to be very nice for designs is to make invalid states unrepresentable in code. So a common thing with a class is to have the concept of invariance, so that with a class, you'll have multiple members of that class, and they relate to each other in some way. So you will say, it's common to see comments that say, this member should only be set if that other member of the class is set to this other thing. And so there's a dependency there. And sometimes you'll have an actual enum and to represent what state you're in. And you'll have a bunch of fields that should only be set for one state and a bunch of fields that should only be set for another state. And it's an error if you ever have all of these set. And then you have to do runtime checks to make sure that you're not violating that. With a variant, you can bring this into the type system, and you can say, all of these fields belong to this state, so we're going to just put them in a struct, and all of these fields belong to this other state, and we'll put them in a struct, and then we'll have a variant that is either this struct or that struct. And now you've brought it into the type system that I'm either in that state or this state, and I just can't be in anything else. I can't possibly set these fields and those fields at the same time. You don't need runtime checking anymore. You have this just defined in the type system itself. And that really, I think, improves, gives us more flexibility and more power in our designs to encode that up front and fewer bugs to chase down after the fact. So I like that. I haven't had a circumstance to use variant for that yet. but I'm sure I will at some point. String view and span. String view is an interesting concept. It's to look at a string that you don't own. So you don't own the memory to it. You're not responsible for cleaning it up. It is responsibility of the coder to make sure that the underlying string is actually valid. Because, well, in C++, we have lots of different ways to represent text. You can have a character array. You can have a character pointer and a length. You can have a character pointer and a null terminator. You can have a standard string object. You can have a custom string class. You can have a string stream. Like, there are many, many different ways to represent strings in C++. I have seen many different shops that just write their own string class with various semantics. And sometimes it's a class that owns the underlying character array and holds onto that memory and is responsible for cleaning it up. And sometimes it's this kind of string view thing where it just views that string over there and isn't going to own it or clean it up. So strings are complicated, and there's ways to do it well and poorly. And trying to consolidate this, I'm glad this is in the language now, because if you're writing an API that takes a string, a common way to do it was to take a character pointer and a length. That's the C way of doing things, and you'll often have this kind of API level thing to say, pass this kind of thing in. And then you might also have a convenience function by the same name that takes a standard string object. This way, your function can be called if the caller already has a standard string object, or if they don't. This way, they don't have to construct a standard string object in order to call your function. But if you have multiple parameters of these, you might wind up, having n squared number of instances of your function if you're trying to say, okay, every single one of these could be a standard string object, or it could be pointer and a length. And now that can all be wrapped up in a string view. So you can have a function, it takes a string view, and you're done. A string view object can be implicitly constructed from a standard string. It can be implicitly constructed from a character array. It can be constructed from a pointer and a length. It can be a substring of another string view. It's just a very versatile way to look at things. The risk is if you partially embrace string view. If you have multiple levels of your stack that take string parameters, and some of them only take string view, and some of them only take standard string, then you get into a messy situation where you take a standard string, you call a function that takes a string view. Now you've looked past the standard string, you're only looking at the underlying character array within the string view. Now that function calls something that takes a standard string. Now it has to copy all of that text and construct a new standard string object. And so if you go back and forth between, in your call stack, between needing a standard string and needing a string view, it can get messy, and you can wind up needlessly copying strings an awful lot. So this is another one where you got to be careful when using this. It is a better way to do it this way, but the transition of getting there, if you have a mix of string view and string reference functions, can get a little messy. So just something to be aware of. Span is the same concept, but where string view just looks at character arrays, span is arrays of anything. As long as it's a contiguous block of something, you can have a span for it. So it could be a vector, it could be a literal array, it could be any subslice of any of those. And that's also a useful thing. Some of the code I was just dealing with earlier this week was code that has a large vector of stuff, and it needs to process it by sending chunks of it off to another system. So it grabs a bunch of them, batches them up and sends them off, and then grabs the next batch and so on. But it has to be careful not to overrun the end of the vector array. So it has some extra logic that it has to put in there. It has to do a for loop that uses I that starts at 0 and increments by the batch size that we want to use, and so on and so forth. And using span actually makes that a lot cleaner. You can say, I have this span I want to process, and I want to divide it up into these subspans. And making a subspan already takes care of not going past the end of your current span. So that can clean up that code a little bit. So string view, span, useful things that I like. And lastly is source location. This is one that I've actually used a few times, and it's got some interesting quirks to it. So source location contains information about some location in your source code. It tells you what file you're in, what line number, and I think it has some other things, but those are the only two that I've ever cared about. And it lets you do the following. If you have some API that has some signature, and then you add a new parameter at the end of it to take a source location, and it calls, it's got a default value to get the current source location, that is processed at the call site. So every call site is going to call source location current and pass the resulting source location into this function, which means that within this do something function, you will see the call site's source location. So now you get the power to see who called me, like what part of my code base is calling this function. And that can be a useful thing. I wrote a little module that, glossing over some of the details, it was a sort of logger thing that I could gather a bunch of information and hold it in memory, but not actually flush it to the log until some condition down the line was triggered. We had a problem that occurred very, very rarely, but in the grand scheme of things, but happened often enough to be annoying, and we were trying to track it down. And so I wrote this function that could grab a bunch of information, and then if the condition triggered, we can flush it to the log, and then we have all the source location to say every piece of information I had gathered and where it had happened. So I could walk, after the fact, go back and walk through which parts of the code did I go through to get here. And that was just a very useful thing to have. You no longer need a macro to capture your source location. It used to be that was the only way to do it. And we had many macros that existed purely because that was the only way to say, where am I right now? What is my current file and line number? And then it could pass it into something else. And so the macro would expand to do that. So logging mechanisms did this. Status construction actually embeds this now, which is kind of fun. I'll get back to that in a moment. But it's just been a useful thing. We have things that will parse strings into protobufers and crash if it's invalid, and we use that in a lot of unit testing code. And being able to do this without a macro is a nice thing. I mentioned status. All these functions are available in the Abseil project as well, so I've been using them since before they officially got added to C++. They've been very useful things, and we also have an Abseil status object, so you can return a status for a function, and we have mechanisms to propagate that, and it can actually, the mechanisms that propagate a failed status also capture source locations, so we can, at the point where we decide, okay, this is worth logging, we have seen this problem, and sometimes you get a failed status and you kind of expect it and you can handle it programmatically, but sometimes, oh, this is a problem, I need to log this thing. And now we can log, here's the path that this took to get here. So being able to capture source location information is really useful. I like it. It helps with debugging a lot of things after the fact. All right, so that is my talk. Better syntax, things that we could do, but now we can do it much more cleanly. Better features, things that we couldn't do before, and now we can. And this gives us a lot more power, and all of this syntax and features combine to an overall better coding experience. So thank you for coming to this talk. And now we can move on to the Q&A.
Okay, so we have some questions. I think people are really curious about you being an instructor in a C++ instructor, so they have a lot of questions related to that.
Okay.
Yeah, to teaching and how to learn C++. So I guess I'm gonna start with those. I think as a C++ instructor, what would you recommend to improve your understanding of the language outside the work? Yeah.
Improve your understanding. Yeah, that's a good question.
So, yeah, but I think this one is really interesting, because when you're working, sometimes you get used to the things that you use at work, right? And sometimes people get stuck at a certain level. Like I see some of my coworkers, like they really like to answer like Stack Overflow questions because it's outside their normal work, so they don't get rusty and they learn a lot of things. Yeah.
Yeah. Yeah, Stack Overflow has a lot of value and a lot of use. I haven't been there lately, but I used to contribute a lot on there. And to this day, I will occasionally wind up there when I'm looking for some information. I may wind up on a Stack Overflow link. So to learn more, the biggest thing for me is to practice, to just experiment and play around with things. And sometimes that's just finding an interesting puzzle to solve and just coding up a solution just to try it and see what happens if I do this various thing. Many years ago, I came like if you're very new to C++ and just trying to get into it, I came across Project Euler a long time ago, and it was just a whole bunch of puzzles that you could solve. And some of them in the early sections were like things that you could solve by hand with pen and paper, and then it kind of jumped up and it's like, no, you need the computational power of a computer here, and you have to code up something. And then some of the questions would revisit previous ones and scale it up to where your previous solution won't finish in your lifetime. So now you need to come up with a way to do it in a more optimized form. And so it was an interesting way to just get more into C++ and just get practice. It was just, I used it mainly as an idea farm of here are some things that I can play with to get practice in C++.
It's very interesting that you mentioned exactly these things like the puzzles and the problems and the Project Euler, because that's exactly what I do. Actually, I have a Sunday stream in which I solve these kind of problems each Sunday.
Oh, cool.
Yeah. So I think a lot of my audience is it's gonna be really happy that you mentioned this way to improve your C++. Yeah. So next question is, what concepts do you think people struggle the most when learning or relearning C++?
From what I've seen, I do an awful lot of code reviews, and I get folks, like, mostly I'm looking at Google developers. So I'm not looking at people who are brand new to coding. At most, I'm looking at someone who's been coding in Java for many years and has recently transitioned to C++. So I don't look a lot of new developers code. So what I'm seeing from that perspective, I see a lot of folks who are very used to having a garbage collector and not quite familiar with the C++ way of doing memory. And so I try to, in one of my classes, I emphasize this, that we have to be very clear in C++ about ownership of memory. And so we use unique pointer if you're getting anything from the heap, so that this uniquely owns that memory. And we talk about ownership. This owns that memory and is solely responsible for cleaning it up. And then we can grant access to this and say, okay, I'm going to pass a pointer to my private member into this other function so it can have access to this, but I still maintain ownership. And being very focused on that clarity of ownership and that chain of ownership is something that I see some folks struggle with.
Yeah, and yeah, I think a lot of people coming from C are really like used to do certain things from like they do in C, and sometimes they try to do it in C++, but in C++ we have like these smart pointers, right? Yeah. Next question is, so you've been doing C++ for a long time. What's your opinion about old and modern C++? Like, I see this mentioned like very often, like modern C++ and old C++. What's your opinion about that?
I like the changes. Like C++ 11 was a just massive shift in what we have, and it made C++ much, much nicer to work in. I can remember at one point I was leaving one company and going to a new company, and they were asking me, what's your favorite language to work in? And at that point I'm like, well, I've really only worked in C++ and I've dabbled in Java, and I really like that Java has checked exceptions because at that point, the project I worked on was using C++ exceptions and not using them properly and crashing a whole bunch as a result. And the idea that you can check your exception handling at compilation time was just so nice. I was like, this is going to be a great thing. And they said, okay, yeah, but we're going to have you keep using C++. And so I kept using C++, and that has kind of faded into the background, where the exception handling of C++ has become less of an issue for that job. And then, of course, at Google, we actually don't use C++ exceptions, so that's completely a moot point.
Okay. So the exceptions. Uh, a similar one. What are good references to study this new C++, like talking about C++ 17 and C++ 20?
CPP reference is just a great resource. I actually referred to it a bunch in preparing for this talk. Like, it can give you a summary of all the features, and you can click on any of them to learn more. Other than that, like, just the practice of playing around to see what you can do with these things.
Okay. So this one comes from I actually know the person who asked this question, and he trains like high school students for the informatics Olympiad. So his question is, what's your recommended way to teach C++ to high school students?
Oh, that's a tough one.
Yeah, because it's the most used language in this kind of competitions, and these students from high school, they usually have to learn it.
One of the best talks I saw on this years ago was about teaching C++ and saying, we as C++ instructors should teach C++, not C. Because there's a strong tendency, like C++ grew out of C, and so there's a tendency for folks, and I'm guilty of this too, to talk about, here's what C did, here's why we do it this way, and now C++, isn't it so much better than what C was? And so we start off explaining the C stuff and explaining like raw arrays and raw pointers and all these things that we then move on to say, don't use that. Use standard string, use vector, use these better technologies that we have. And for new people starting out, that's often very confusing. It's often better to just ignore all that C stuff. Let's start with, here's standard string, here's vector, here's range-based for loop, here's how to iterate over a container, here's how to put things into a container, and less concern about some of that raw under the hood stuff. We can peek behind the curtain eventually, but when starting out, it may be maybe more helpful to start with those C++ constructs. And the other thing would be to give them an interesting first assignment. Hello World, as famous as it is a really terrible assignment. It's just kind of boring, but having a simple assignment to take some input and do something fun with it is a useful thing.
So this one is about your work at Google Drive. It's what challenges have you had while working at the Google Drive team?
Let's see. I work on the back end with one of the storage layers, and it is just a massive amount of data, and it's kind of mind-boggling scale to process. And I've written stuff that's had to go off and make sure that things are working properly. Like, we have lots of code, we have lots of unit tests, but we also want to have integration tests, and we want to have things that can catch any problem that may occur. And writing something that can process all this data is just is an interesting scale to work at.
So we're getting a lot of questions. So kind of random. Let me try to. So you were talking about unique pointer. So
Mm-hmm.
and the question is, do do C++ has an ownership similar to the Rust language? Like, because yeah, Rust manages the memory with this ownership model, and I think a lot of people, I've seen a lot of people don't know that maybe you can kind of do it more or less similar in C++. Maybe can you say something about it?
For comparing it to Rust?
To Rust, yeah.
Uh,
Or maybe if you're not familiar, yeah,
yeah, I really can't compare it. I'm just not very familiar with Rust. I've heard
yeah,
really good things about it. I heard it has some clever notions that just don't really map back to C++ things. Like I think Rust has a borrow checker thing that we
yeah,
don't do. C++ very much trusts you, the developer. It's like, oh,
yeah,
sure, you're doing that, fine. So my intention when I try to talk about the ownership semantics is to make sure that the developer is thinking about that. So yes, I will have a unique pointer and I will own this heap allocated memory, or I won't use a unique pointer. I will just have a directly instantiated object on the stack or as a member of my class. Like you don't need to wrap it in a unique pointer if you can have it directly be a part of your class or part of your function. And then maybe you need to give access to this thing to some other class or some other function that you're calling. And so you take the address of your local variable, or you call .get on your unique pointer, and you pass that raw pointer, and now you've given access to that function. But it's your responsibility to make sure things like that function finishes doing whatever it's doing and returns. And now you know it didn't hold on to that pointer, and now it's safe for you to destroy your unique pointer. And like you have to make sure that you pay attention to these lifetime things because C++ will not check that for you.
yeah. So we have some questions related to similar languages, so I'm gonna ask you those. This one. So Google just announced recently about Rust support for Android and Rust for the Linux kernel. And so, what do you think about the adoption of Rust or the? I think a lot of us, like C++ programmers, have seen like, a lot of Rust programmers like to invite C++ programmers to try the language. So, yeah,
Yeah, I've heard really good things about Rust, and I know there's a bunch of other languages that are becoming popular that
yeah,
I'm happy to see grow. I'm happy to see these other languages do well, and someone comes up with some clever idea for language. And a lot of these features that other languages start doing wind up coming into C++, and a bit of vice versa. But I mean, C++ is the older language, so like they started with that
yeah.
point. So anything new that these languages come up with that they can show work well, like we've added some of these things, and we added Lambda support in C++, and some of these other things that just make C++ a better language. So I'm happy to see the competition. And everyone keeps telling me I need to try out Rust, so maybe someday I will.
They're very enthusiastic, like especially with C++ programmers. Like they like to invite C++ programmers to try Rust. Uh, so, uh, so can you mention something about your opinion about concepts that they're coming for? I think C++20. Yeah, maybe some overall. Uh, it doesn't have to be very technical, but just what's your opinion about concepts?
I don't quite see. I'm not quite sure what to make of them yet. And I mentioned lambdas a moment ago, and lambdas are just a super useful feature of the language right now. But when it first got added, and I was reading through like, here's the list of new things being added in C++, and I was like, lambda. Let me click on that, read the details, and I thought, okay, lambda, that's an interesting academic exercise, but I really couldn't see the value in it. I couldn't see how I would actually use that in day-to-day life. And I have since learned. Like this has now become an integral part of how I write C++ code. It has massively changed the way I write code. And so Lambda is just this sort of key point for me where I'm like, okay, I don't know things, and I'm excited to see what other people will teach me. And like people showed me how to use Lambda properly, and I got to play with it, and it was just super useful. And so concepts, I'm not quite sure what to make of it. It seems like it could be a useful thing. I'm not really sure how I would use it, but I am very excited to see what other people can show me.
Cool. So, with respect to scoping, you begin your talking about scoping. I have one question. We have one question about it, and if you
Okay.
can define several variables in, or just one, like in, I think he referred
Oh, in the
yeah,
initialization section,
yeah, yeah, yeah.
that is a very good question. I think you can do more than one. I've just never tried it.
Mm. Yeah, I think the most common use case is the one that you mentioned, right? So
Yeah.
only one. Like, okay, this one is more or less personal. You have a long and successful career. Is there a feature or system that you feel most proud of? Yeah, very personal question.
A feature or system I am most proud of. That is a tough question. I like taking on challenging things. A common thing from most of my career has been to take on part of the project that other people didn't want to take on. Or early on in my career, there was a part of the system that was a legacy code thing that other people were afraid to touch. Like it was this fragile, brittle system, and people were nervous that they might try to make a change and accidentally break other things. And it was known to crash a whole bunch. And I was proud that I was able to take that on and say, you know what, I'm going to step up and clean this up and make it more robust. And that sort of carried through, that I like taking on older code and making it cleaner and more robust.
So, okay, this one. What's the feature that you think C++ doesn't have and you would like to have? And if you could have one feature that.
I do miss using exceptions. We don't use them internally at Google because there were performance costs to it, and there were plenty of problems with like lots of code was not written to be exception safe, and you don't have checked exceptions in C++. So I really wish C++ could embrace exceptions as part of the type system in a way that you could check exception handling properly at compile time.
So this one kind of related. What is of the new features? Which one is your favorite?
Of the new features, which is my favorite, like from my talk there.
Yeah.
So the library changes are things that were already added to the Abseil project. And so I was already using those long before they got added officially to the language. But I would say probably the designated initializers and structured binding are just things that I use all the time.
Yeah.
And that would probably be my favorite, structured binding.
Yeah, for me too. I use it a lot. Yeah, the structured binding. Uh, this and we have regarding the changes. How do you think it affects like memory or performance? Do you think it changes a lot in performance, or it's just related to other things like that you mentioned?
The things I highlighted here, for the most part, I don't think will have a performance impact. The scoping changes might have a lower overall memory footprint. How much and whether you notice is another matter entirely. And then there's, of course, the performance degradation if you wind up using some of the libraries and accidentally copying and creating lots of new standard strings all the time. Especially if you're doing string to string view to string to string view to string to string view, you just copy it way too many times, and then you would see a regression. But overall, I would say minimal performance impact from these.
Yeah. This one is kind of a specific, and I'm not sure if, but yeah, this one. How do you go about unit testing mathematical operations such as compression algorithms? Very specific.
That is a very specific question. Okay, mathematical operations such as compression algorithms.
Unit testing of those.
Yeah, unit testing. I love unit testing. One of the classes that I teach for C++, we cover unit testing, and I really enjoy explaining some of that and showing people how we can write better unit tests. And I'm a bit of a unit test evangelist where I'm like, people write unit tests, please. It helps for maintainability so much. So for mathematical operations, that one is a bit more messy. Generally, like normal mathematical operations, I don't worry about it because like add, subtract, multiply, and divide, like that's not something I need to test. If you're writing some special operation that you want to test it, generating some test cases that cover a wide span of things, and then basically going through like these inputs should produce this output, and having that saved somewhere so you can load up a massive number of test cases and march through them. That would kind of be how I'd do it.
Yeah, I think those are almost all the questions. We just have one comment, like very practical talk, and people are really excited to try this like in their own code.
Good. Well, I hope it was helpful. Like, I love talking about C++, but I love it even more if like it's actually useful to folks.
I think you can start like using a lot of these like right now, especially since I started using the structure bindings. I can't stop using them. Each time I have to, especially for maps. It's
oh yeah, range-based for loop with a structured binding. Yeah. Best way to iterate over a map.
Yeah. And yeah, I think those are all the questions. And well, thank you for coming. I think we really.
Yeah, my pleasure. Thanks for having me.
Enjoy your talk, and I hope we can have you again in some time. Yeah.
Yeah.
Maybe you will fall in love with concepts, and you can come talk about it. Yeah.
Sure.
Yeah. Okay. I think I'm just gonna wrap up the meetup, and thank you.
All right, thank you.
Ok, bueno, esa fue la plática con Team Chestnutt. Si tienen algún comentario pueden dejarlo en YouTube, donde se quedan guardados. La plática queda grabada en YouTube. También queda guardada algunos meses por Twitch. Y bueno, aunque nuestro speaker casi no usa Twitter, si tiene algunos, si lo quieren seguir, pero no lo usa seguido. Lo voy a poner aquí. Es Team Chestnutt. Lo pueden seguir aquí. Y bueno, le agradecemos por su plática. Esperamos tenerlo pronto. Creo que disfrutamos de la plática. Fue muy práctica y son cosas que pueden empezar a usar ahora mismo, ¿no? No hace falta que sean ningunos expertos. Es como para todos los niveles. Hay cosas muy útiles de C++ 17 y 20 que podemos usar. Y pues ahí si pueden dejarle algún saludo, agradecimientos en el chat, seguramente también los verá. Eh, y pues esperamos hacer estos meetups cada mes, pero es un poco difícil. En especial en español. En especial en español es un poco difícil encontrar speakers que hablen, bueno, que hablen C++ también, se puede decir. Eh, pero creo que las dos pláticas que hemos tenido, bastante buenas, me han gustado bastante. Quiero agradecer a los speakers que han venido, estamos muy agradecidos. Pero la próxima vez sí logré contactar a la próxima vez vamos a tener dos charlas y van a ser en español. Una de un compañero latino, también está en Google, y una plática sobre un unit testing. Las dos van a estar muy buenas y esperamos hacer los meetups mensualmente. Entonces el siguiente meetup va a ser en julio. Aunque bueno, como les digo, no es nada fácil encontrar speakers de C++ y mucho menos speakers de C++ que hablen español. Pero bueno, mientras tanto pueden ver las grabaciones de las dos pláticas que creo que han estado muy buenas en YouTube. Están grabadas, ¿vale? Aquí están nuestros medios de contacto, el Twitter de nuestro invitado de hoy. Muchas gracias. Y bueno, pues nos vemos la próxima. Hasta luego.